Moving along in the notes on Got It number 1, we have to be able to find all the rational roots of this polynomial. So the first thing we're going to do is we're going to list all the possible roots. Okay. So to list the possible, you use plus and minus of the constant, the factors of it, and plus and minus of the first. So the factors are 8, plus and minus 1, plus and minus 8, plus or minus 2, plus or minus 4. And then you're going to put those all over the factors of the first, plus or minus 1, plus or minus 3. Now when I say the factors, I'm just talking about the things that multiply to be that number. The next things we need to do is we need to take all of these options and plug all of these options into this equation. But I'm going to take a shortcut. I'm going to use your calculator. Okay? So I'm going to type your equation in. And I'm going to hit second table. Now remember, by hitting second table, I'm going to be able to plug in any values I want into your calculator. So I'm going to start with plugging in 1 over 1, or plugging in 1. So if you want to write down the ones that we're going to plug in, we're going to plug in plus and minus 1, because 1 over 1 is 1. Neither of those made 0, so neither of those is a 0, or a rational root. So now I'm going to do 1 over 3. So negative 1 over 3 and positive 1 over 3. Neither of those made 0, so I move on. I'm going to do 8 over 1. So you do plus or minus 8. Neither of those made 0, so again, none of those are the answer. Now plug in 8 over 3. I'm going to go back up to the top. Neither of those made 0. If none of those make 0, move on. So plus and minus 8 over 3 does not work. Now try 2 over 1. Well, 2 over 1 is 2, so I got to try plus or minus 2. Neither of those made 0, so move on to 2 over 3. So negative 2 over 3 and positive 2 over 3. Finally, we get one answer that works, and it was the positive 2 over 3. So I'm going to put positive 2 over 3, give it a circle, because that is one that worked. Okay, move on and try 4 and then 4/3. So we're going to try plus or minus 4, and we're going to try plus or minus 4 over 3. Okay. Try, go back up to the top, 4, negative 4. Neither of those worked. 4/3 and negative 4/3. Neither of those worked. So the only rational root is positive 2 over 3. Now, you should notice that this problem should have 3 total roots because it had a degree of 3. That just means that if 2 over 3 is a rational root, that must mean that the other 2 of them must be irrational roots. Moving on to Got It number 2.
So let's take a look at part 2. It says, what are the rational roots? So I'm going to do the same thing. Check that it's equal to 0. Again, hopefully you're listening. Otherwise, this is a random equals 0. It looks like I look like zeros. We will do plus or minus the factors of the last number, which is 6. So 6, 2, 3, and 1. And then the factors of 2, 2, and 1 on the bottom. So I'm going to check things like 6 over 2, which is just 3, 2 over 2, which is just 1, 3 over 2, 1 over 2, and so on and so forth. Let's see how many. Remember, there could potentially be 3. Potential, not exactly, necessarily. Go to y equals, and you could type these in by hand, although that would be painful. So I would not encourage it. If you have a graphing calculator, utilize your tools. So there's my equation. Second graph to plug them in. Again, you could be doing these by hand. I am going to try plugging in 6 over 2, which would just be plugging in 3 and negative 3. Okay, those definitely didn't work. So now I'm going to try plugging in 6 over 1. So 6 over 1, negative 6 over 1, which is just 6. So those don't work. Now I'm going to try plugging in 2 over 2, which is just 1 and negative 1. Ah, I got 1. So negative 1 gives me 0. Negative 1 is one of them. Now again, you could do synthetic division with negative 1 if you want. And then when you get an x squared, You can just do the quadratic formula after that. But I'm going to sit here and I'm just going to kind of keep guessing. I did 3 and negative 3, but I don't think I did 1/2 yet. So let me try 1/2 and negative 1/2. Okay, those did not work. Now I'm going to try 3 over 2 and negative 3 over 2. Oh, there's negative 3 over 2. Negative 3 over 2 gave me a 0. And that came from this 3 and that 2. So negative 3 over 2. So far I have 2 answers. Now let me see if I can get my next answer. I'm going to try, did I try 1 over 2? I feel like I'm missing 1. Maybe I should cheat and look at my old answer key. But let's try. So we did 3, we did negative 3, we did 2, do we do 2 and negative, do we do 2? Aha, look at that. 2 gave me 0, so I wasn't finding it, but it's because somehow I missed plugging in a positive 2. So I found all 3. Those are my 3. They're all rational. Again, if you want to do synthetic division, break it down to an x squared, use your quadratic formula, you could. All right, let's take a look at this problem here. But I think my old video does a good enough job doing this one, so I'll lead you to my old video.
And got it number 3. It applies this idea up here of using conjugates for things that are irrational, okay? So in got it number 3, we can see that we have a cubic polynomial, which means, you know what cubic means. It means it has a degree of 3. This polynomial has real coefficients. That just means it kind of applies to what was above. They are telling us that 3 minus 2i is an answer. And they are telling us that 5 over 2 is an answer. They're asking us, what is another root? If we know that these two are roots, what's another root? Well, since this one is imaginary, what that implies is that 3 plus 2i is the other root. So if we have 3 minus 2i, it implies that 3 plus 2i is the other root. Now you might be asking, does 5 over 2 imply anything? This doesn't imply anything, so I'm going to write implies nothing. And the reason it doesn't imply anything? Because it's a real rational answer. Just because it's a real rational answer does not mean that negative 5 over 2 is an answer. It only works for kind of the goofy answers that are square roots, or the goofy answers that are imaginary roots, not for rational roots. Moving on to the next, got it. Number 4. It asks us what quartic, now you know that means it has a degree of 4, polynomial has these zeros, or these roots. Well, the first thing I need to know is that if 2 minus 3i is an answer, that implies that 2 plus 3i is an answer, because of the rule that we just talked about and got at number 3. Now, if we know 2 minus 3i is an answer, we know 2 plus 3i is an answer, they also tell us 8 is an answer, and they also tell us that 2 is an answer. What that means is that we have to put them back into parentheses and resolve. So this is where it's going to take a little more time, okay? In every single answer, we put the opposite of what we see in. Let's start with the easy ones. If 8 is an answer, that means that x minus 8 would have been in your parentheses. If 2 is an answer, that means that x minus 2 would have been in your parentheses. Now I'm going to talk about the harder ones. If 2 plus 3i is an answer, that implies that x minus the quantity of 2 plus 3i was an answer. And if x minus 3i is an answer, that implies that x minus the quantity of 2 minus 3i was an answer. So the idea here is if you have a binomial, you have to remember to subtract that binomial using parentheses. Now why would that be so important? Because we have to distribute our negative in and rewrite it one more time. So this first parenthesis becomes x minus 2 plus 3i. by distributing our negative in. This parenthesis becomes x minus 2 minus 3i when we distribute our negative in. And this parenthesis becomes x minus 8, and they stay at x minus 2. The next step we have to do is FOIL all of these things together. So I'm going to start with the harder two, and I'm going to multiply I'm going to multiply the trinomials together. So x times x is x squared. X times negative 2 is minus 2x. Minus 3ix minus 2x plus 4 plus 6i. And it keeps going. So I'm going to have to do the 3 now. Plus 3ix minus 6i minus 9i squared. The next thing we need to do is remember that 9i squared or minus 9i squared is really a plus 9 because I squared is negative 1. So I can see that I am going to have the quantity of x squared minus 4x when you put your x terms together. The 3ix's cancel each other out, and you are left with a constant of 13. And we are now going to multiply these two binomials together. I'll put the answer right here. So we're going to get x squared minus 2x minus 8x and then plus 16. I'm going to combine my two like terms together and put it here. X squared minus 10x plus 16. And the last thing we need to do is multiply these trinomials together. So one more time, we get x to the 4th minus 10x cubed plus 16x squared minus 4x cubed plus 40x, and then 4 times 16 will be 64 minus 64x. And I'm sorry, on the 40x, this should be a squared. I just missed that. And now we have to do the 13 plus 13x squared. Okay, so 13x squared and minus 130x. Almost done. And then 13 times 16 is 208. All right. Last step is we get to put all of this stuff together. So we have an x to the 4th and just enough room for it. When you put all of your cubes together, you have negative 10x cubed, negative 4x cubed, and those are it. So you get minus 14x cubed. You look at your x squared, so you get a positive 16x squared, a positive 40x squared, and a positive 13x squared. So a positive 69x squared. And then you look at your x's. You will get a total of 194 because you have the negative 64 and the negative 130. So negative 194x. And then last but not least is your constant of 208. And that is how you take different answers. You have to FOIL them all together, but then you'll get the original polynomial that they came from. The last got it is got it number 5. And we're going to use Descartes' rule one more time, and we're going to talk about the real roots. Now we do know that there are positive roots and that there are negative roots. So we're going to determine how many possible positive and how many possible negative there are. So the first things first is we got to count our sign changes. And so first we're going to talk about the positive, okay, the positive real roots and how many there might possibly be. Okay, here we go. in order to do that, we're going to count our sign changes. So, I see I have a positive 2. Actually, I'm just going to write it down again. I'm writing my original down, and then we can count them a little better. Okay. So I have a sign change here. That's 1. A sign change here. When I say sign change, I mean from a positive to a negative. So that's 1. That makes 2. And look, positive to a negative. That makes 3 sign changes. Since there are 3 sign changes, here's what that implies. I'm going to write because I have 3 sign changes. That means there are, and here's the trick, 3 or, got to back off 2, 1, or maybe I should say there is 3 or 1 positive real roots. So you count your sign changes and then you back off 2 until you can't back off anymore. So we can't back off 2 because we'd be in the negative. So you have to remember to take away 2. Okay, let's do the negative real roots now, okay? So negative real roots. Those are more difficult. You got to plug in a negative x. Okay, I'm going to take this slow. So that would be like 2 times negative x to the 4th. Notice how I'm using parentheses. Minus negative x to the 3rd. Make that nice and apparent. Okay, then plus 3 negative x squared. And then minus 1 equals 0. So let's talk about this. A negative 4 times will end up staying as a positive. Now a negative, look at what I'm pointing at. A negative 3 times will be a negative. That's going to change this to a plus x cubed. A negative square keeps what it was, so it keeps a positive 3. And then the minus 1 chills out in the back. Now let's count our sign changes. Positive to positive doesn't change. Positive to positive doesn't change. Positive to negative, that's the first sign change I see. So here's what we're going to say. The sign changes 1 time. So there is 1 negative real root. I can't back off 2, otherwise I would. So once you get to 1, there has to be 1 negative real root. Has to be. So what does this look like on a graph if I were to show you? Okay? Let me show you. I'm going to put this original problem in there. 2x to the 4th minus x to the 3rd plus 3x squared minus 1. We'll be able to see it crosses. Take a look at it. If I zoom in, it crosses once in the negatives and once in the positive. So if you want to draw yourself a little picture, it crosses once in the negative. There's your 1 real negative. Oh, sorry, not in the video, am I? It crosses once in the negative, so there's your 1 real negative. And remember how we talked about it crossing either 3 or 1 times in the positive? It only crosses once, 1 time in the positive real roots. Okay? So we have the option of it crossing 3 or once, and when we actually do the graph, we see it only crosses 1 time.